everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about designing for reliability, and it's brought to you as a part of Mobius Connect's ongoing YouTube series, Connect Conversations. I'm Kim Fugger, the manager of Mobius Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce our hosts of the Connect Conversation series, Global Reliability Improvement Expert Doug Plucknett and Ron Moore. Hello, guys.
Hello, how are you doing, Kim?
Good. How are you? And just so everyone knows, we are just waiting on Ron. He had a video issue, so as soon as he connects, we'll get going here a bit. But before I officially pass the microphone over to you, I just want to encourage our audience here today to submit any questions that they have at any time today into the chat function, and Doug and Ron will be more than happy to answer your questions throughout our time here today. Your questions will be aired anonymously, so don't feel like you're going to get called out. And Doug and Ron are here to provide their advice and perspectives from their experiences and are here to help you. All right, Doug, as we wait a bit for Ron, I'm going to go ahead and pass it over to you.
All right, Kim, thank you. So today we're going to talk about design for reliability. And of course, Ron put together most of the agenda for today. So at this point in time, I'm going to talk about some of the things that I added to his agenda once he put it out. I could tell you that many years ago when I was involved in this, we put together a team at Eastman Kodak Company to talk about what are we going to do about our capital projects and how are we going to design for reliability. And we had a process that we called the 5 rights of reliability, which was design it right, install it right, manufacture it right, maintain it right, and store it right. So we covered all those different issues as part of the design phase for our projects. And we even put that in as a step in terms of our gates for our capital projects. One of the things that we did is once we got to the point where they decided, okay, this is a piece of equipment that we're going to look to design and install. We talked about reliability block diagrams in the very front end of this to determine what level of reliability are we looking for. And once that was determined, then we got into the point where we'd say, all right, as the group starts looking at and putting drawings together, P&ID drawings, for example, we would then get into things like failure modes and effects analysis, FMEA. At the equipment level, you can do FMEA obviously at different levels of a project, but starting out at the equipment level, looking at high level at things, right? If we're making a new film machine, for example, starting with the front end of that process, what does the extruder need to do? What are the components of it? What level of reliability does it need to run at? And how is it going to be powered? What operating temperatures and pressures does it run at? Looking at how long we would expect it to be in service, right? So there are some products that we would run several weeks at a time, some 2 and 3 months at a time. So if you're running at that, what level, what pressure, temperature, and flow is needed to achieve that? And we'd put together a group and sit down and go through and perform these failure modes and effects analysis so that we would understand right from the get-go what our design is. And of course, in doing that, we had a cross-section of people that were involved in that on the mechanical end, the electrical end, the instrument end, and of course, the folks in engineering were highly important in terms of what type of footprint are we looking at, the maintainability of it at that. We would consider safety and quality as part of this as well. So a very thorough first pass, so that by the time we got to the point where we were actually making P&ID drawings, and then we would do a component level FMEA. So that was where we stood on the front end. And then moving forward from that, on the safety piece of this, we then involved our folks from the safety organization, have them come in and take a look at this particular design in terms of exposure to employees. What are the hazards that might be involved? The environmental piece of that as well. What chemicals are in this, and looking at the MSDS sheets and so on, and moving on from that. So from there, once we got to that, we would then start talking about, and I see Ron is coming in, what the components we would be using, the manufacture of those, the reliability we had seen of those in the past, and what our expectations were in terms of electrical piece, the drives, motors. And it looks like Ron is still having video issues.
Oh, there we are.
Ah, there he is.
Not that you want to see me. No. So it's not a pretty face anymore, like it used to be. So go ahead, Doug. I'm sorry about your electric motors. You go ahead and I'll
Yeah. So one of the things we did as a company was we looked across. We had our own motor shop for a number of years because it was a large company and a very large site. So we had our motors down to, I believe at that time, 3 different brands that were allowed to be used in our designs. That kept us, as we talked about a couple of weeks ago, in terms of keeping our stores inventory under control. And doing that, our motor shop said, all right, here's the 3 brands that you can use because we found these to be the most reliable. And that kept our parts to a minimum, and it also gave us the reliability on the front end that we were looking for. So what I did, Ron, is I just immediately talked about the 5 rights of reliability that we use at Kodak in terms of our design for reliability process.
Yeah.
So
okay. Was it my turn?
Yes. Jump right in.
Well, what I've done is I've gone back through, making common sense, common practice, and back through some other things, some previous work. And, I guess I want to do 2 things. One is I want to share some case studies because that's how this thing was built. And maybe after we share those, I want to go back and talk a little bit about, maybe it's the same as your 5 rights. I missed that bit, but I'm sure it's very similar. But just some case studies on how badly you can go wrong if you don't start with a design and design for reliability. I'm just going to rattle off some of these, and I'll pause in between. You can jump in as you see fit, Doug, or throw out another case study. And by the way, I used Teams last night for a webinar, and several nights before that. I don't like Teams. It's awful. I think it shut down my camera. And so there. That's my endorsement of Teams. It just sucks. Moving on. And I don't want a phone call from Microsoft. I don't care. Moving on. There was a big LNG plant that I worked with, and one of their parts of their process, of course, had heat exchangers. And these heat exchangers had carbon steel tube bundles. And they had evaluated using titanium. Well, of course, titanium is really expensive. In fact, they figured it might cost $10 million to replace all the tube bundles with titanium. And they went through an analysis for the payback, right? The payback based on the maintenance costs they were incurring compared to the replacing them and how long it would take them to get it back. And they concluded gosh, it would take several years, maybe 3 or 4 or 5 years to get that money back just based on maintenance costs. And so my comment was, well, wait a minute, what are you losing in production while you're plugging those tubes and shutting down part of the plant and so on and so forth? Well, come to find out that replacing the tubes would pay for itself in 1 year if you account for the production losses and the gross profit on that, plus the maintenance costs. And by the way, that didn't even count the maintenance costs. So the point being here, you can't just look at maintenance costs when you're looking at the impact of an unreliable system. You have to look at it holistically. What are your production losses? Moreover, what about yield and quality and customer impact and so on? So that's one, just little case study of thinking too narrowly about the business impact on a crappy design. Doug, do you have any comment on that one?
Yeah, just for those folks that aren't familiar with the tube bundles, when Ron talks about plugging them, if you have a leak in a tube, what they'll do is they'll pull the head off of that bundle, and they'll take a taper pin and smash it down into that, so it basically makes that single tube dead. And companies will do that a number of times before they actually replace the entire bundle. But it is a very intrusive thing to do. It certainly takes a lot of time. And every time you do that, especially if you're talking something that runs at pretty high or very low temperatures, you're talking about a significant amount of time to get that piece of equipment ready to pull apart, put back together, and restart. And that's where the huge loss comes in, is that you're not making any product, so you're not making any money, right? Yeah. And if you're in a sold out position, it's huge money.
Yeah, and they did. And the other thing that happens too is if you plug enough of those tubes, then you have to derate the process, because you have to run it at a higher or lower temperature, as the case may be. Yeah. So anyways, just a thought. Now, another one, it was at a plant, big chemical plant, and the design guys had decided to scrimp on isolation valves. Not enough of them. And instrumentation, not quite enough. So it was more difficult to control the process. And these things were difficult to access. So it made maintaining them really difficult. And the problem with this is, if you don't have enough isolation valves, or with them in particular, they had to shut down the entire plant just to work on a part of the plant. Whereas if they had sufficient isolation, and in some cases, I don't remember for sure, probably had double isolation for safety purposes, they could have run the rest of the plant, put some of that in storage tanks, and then, continue the process, and it wouldn't have nearly as big an impact on production. And they were losing something on the order of $3 million a year because they didn't have adequate isolation capability and adequate instrumentation. And that, again, that doesn't even count the tough time you have doing maintenance on these things when they're difficult to access, or the fact that you have to maintain stuff more often. So that's another one. Doug, you got any thoughts on that one?
No, but I do have another case study that I did with a company, and this was a real interesting one because they had this piece of equipment, a deodorizer, going into several plants. It just so happens that they had made a purchase of a competitor, and that was one of the things the competitor had not done, was sufficiently deodorize their process so that their neighbors didn't have to smell what was going on. Right. So we took what was their standard design and did an RCM with a team. And that was one of the things that I had pushed with one of their reliability leaders is, when you're spending that amount of money on capital, it was a significant amount to install these things. It made them, number one, more environmentally compliant for their process. But it took us, I believe, 7 days to get through this process doing the RCM, where we talked about uh, what are the maintenance tasks that need to be done with this, but what are some of the things that may be missing from this process that would make it easier to maintain? What are some of the issues that the operators have had with ones in the plants that they did have deodorizers? Because, as I said, they're buying a competitor, so they did have plants that did have deodorizers. So we brought a couple operators and maintenance people from those plants in and talked about issues they had with running them, starting them up, shutting them down, isolating for things like you're talking about, having to replace heat exchangers and things like that. So it took us a good 7 days to get through this, but the end result was quite fantastic, because the area that we did, or the site where we did the RCM, their punch list for things that needed to be changed after they did the installation and started up was 2 items, and they were very small. Both of them less than $5,000 in terms of changes, so less than 10 grand. Their startup occurred, and they made accreditation within 3 days, right? The plants that did not, some of their punch lists were 2 and 4 pages long, and over $100,000 in changes, right? And it took them weeks to get started. So it was one of those things. It was quite plain to see to them to say, gee, it's worth the money to upfront get people in that have experience with these things and talk about some of the issues that have. And I mean, there was some really great things that came right out of the operators in terms of, hey, one of the issues we have with these is people making mistakes in terms of valve position. So when equipment's in the normal operating position, if the valve handle is supposed to be in the open position, let's make those handles green. And if the valve is supposed to be closed, let's make those handles red. So it's very evident which position the valve is supposed to be in during normal operating condition, right? It's because there are a lot of hand valves there. Now, of course, it would have been nice to automate a lot of those things, but then you get into another big pile of money, right? They eliminated head knockers and all kinds of issues that they had with the other sites, issues where they had trouble getting components out because of the way they were pinched in with the piping, right? So really a big change, and one of those eye openers that it was one of the things that it made me a busy person with that company for quite a while, right?
You appreciate the business, right?
Yeah, absolutely. Right. And they appreciated the eye opening to go, wow, why have we been making the same mistake over and over again for years, you know?
Yeah. Well, another, and you made I think a really critical point, and that is in the design phase of a project, you need to have folks from operations and from maintenance who have operated and maintained similar equipment, so they can advise you on whether or not you're doing a reasonable job with all this stuff. So it's just really, well, it's just really important. Another case study, a plant, they had decided to buy different pumps and different isolation valves. These were because they were cheaper. Of course, right? You got to get it in under the payback or whatever the capital budget that you have. So these pumps were cheap and they were non-standard. And so they had non-standard parts, and the folks that maintained them in the machine shop, they had to relearn how to maintain these pumps. And long story, and they had a compressor, a big, huge compressor that was bought based on low bid, which would flop over often. And the combination of all this was resulting in maintenance costs that were running about 6% of replacement value. And now that might be compared to, say, 3 or 4% for even a mediocre plant, or 2.5%, 3% for a really good plant. But more importantly, they were losing $5 million a year in production. So it just highlights the fact that, hey, try to get it right in the first place. get your operators involved, get your maintainers involved up front in the planning and preliminary design phase. So, and then I've got one more bigger case study. It's an entire plant, where we did some things. But before I rattle on, Doug, you got another one you want to share, some comments?
No, not at this point.
Okay. Well, and like I said, we want to come back to what you call the 5 rights, what I call the reliability process in just a minute, and just throw out some questions to consider when you're doing all this. This last case study, and I'm sure the folks out there have been through any number of their own personal case studies for all the screw ups that you have to live with after somebody hands it over. But this was a large chemical operation over in England. And they had built what we'll call the Noki 1 plant. And over the process of building that and starting it up, it took them 18 months to come fully online from startup. 18 months. And they had repeated process instability issues where they had to shut down, stabilize the process, start up again, lots and lots of equipment failures. And of course, when you have that many failures, you don't have enough parts, and that creates all kinds of problems. And thrown into the mix there was, of course, training for the operators and the maintainers that hadn't been done particularly effectively. So most of them were learning on the job during the startup and the operation. And that just led to all kinds of difficulty. Now, in spite of all that, in spite of their, wouldn't even call it mediocre performance, and in spite of their disastrous performance, the market was really good. And they could sell everything they could make. And, the guys on high thought, well, in spite of this, we probably ought to build another plant, because they were anticipating over the coming years that the market was just going to explode for this product. So they decided, let's build a second plant. And one thing that did happen is they were determined not to repeat the errors that they had made on Noki 1. So they went back to the powers that be, and they requested additional money to address those problems in the design. And they had a lot of the guys from Noki 1 on Noki 2. And in fact, the project manager for Noki 2 was the same guy as Noki 1. Now, in most companies, what would have happened to the guy on Noki 1, the project manager who had a disastrous result? Well, he would have been working somewhere else. His butt would have been out the door in about a heartbeat, for the disastrous performance. But, he was basically a good guy. He was handed a budget that, he really couldn't deliver what was expected with that budget. And anyways, and he knew where all the warts were. He knew where all the glitches were. So they put project team, shop floor guys on the project. They started going through, how are we going to design this for life cycle cost? How are we going to address all the screw ups we made on Noki 1? And things like, they updated their process control system so they wouldn't have as much instability. They used stainless steel in a lot of areas instead of carbon steel, because it was a very corrosive and erosive environment. They standardized on some pumps that they felt were reliable. They just had more robust equipment in general, and they improved the access to the equipment. And they had better installation criteria for fit ups, access, and so on, so that, greater precision in the installation and startup area. And as a result of all this, they came fully online within 2 months. Up, running, and stable. In fact, after that, they were consistently more stable, more reliable than Noki 1. And you say, well, they were new. Yeah, well, that's certainly part of it. But more importantly, wasn't the fact they were new. they had addressed all the defects associated with Noki 1. And anyways, one really interesting thing that happened though was, they had budgeted an extra whatever, let's say 10% to address these issues. They didn't spend it. You say, whoa, wow, how'd that happen? Well, they saved enough money on the construction area. They didn't have nearly as much rework during the construction phase. And so the money they saved on the rework that they had on Noki 1 more than made up for the extra budget they put into the capital project budget. So that was a real, wonderful thing that happened. And the other thing, which is kind of subtle, it's one of those soft things that happened, is there was a shift in the culture of the organization. Noki 1, it was firefighting and, going crazy every day, trying to get the plant to run, get it back online, get it fixed, get it, right? Just nuts. Well, Noki 2 thing just kind of ramped up. And then, not to say they didn't have any problems, they had a few, but they were relatively minor compared to Noki 1. And the folks working in the plant thought, well, this is pretty good. I think I might like it here now, as opposed to this place sucks. I hate this place. They're always calling me out at 2:00 in the morning. So it was just, remarkable, the change in what happened between the two plants. And that was primarily because two things happened. One is they had a new VP of operations, a new CEO, and those guys decided, we need to change things here. We need to make it right. And they did, and everything worked out pretty good. So now the only, negative thing you could say about this project is, and it wasn't really there in their bailiwick per se at the beginning of the project, feedstock quality, because of demand for the ore, then the feedstock quality of the ore was kind of growing, poorer. And so they were anticipating further changes to the process so they could accommodate, this poorer grade feedstock. And they were building Noki 3 right shortly after I left. So that's probably that's a really super duper case study. So
Doug, there is one question here, and I'll get to it, but I want to make a comment first, and that a big part of the story you just told, number one, is admitting that you had problems with the first one, right? Because sometimes,
well, it was pretty obvious,
right? You'd be surprised. Sometimes the engineering organization just walks away from it, and they go, "There you go, we're done," right? Obviously they had people that were complaining, saying, man, this thing's a piece of crap. And if we're going to build another one, we better learn from the mistakes that we made. Admitting that you had problems is a big part of that, right? Yeah. Especially if you're keeping that same project manager on that worked for the first one. If he's not one to admit to mistakes, the second one might be identical. And that's definitely not what you want. So we do have a question, and that was, how long has total life cycle costs of ownership been preached? And I could tell you, I've been involved with reliability engineering for quite some time. In the 30 years that I've been involved, that has been an issue the entire time. I'm sure it goes back further than that. But do people pay attention to that? That's the question. Yeah. Right. What the total cost of ownership, because that's where we get into, as you talked about, we can get a cheaper pump or a cheaper motor, and it makes the capital project look good. But in the end, you're spending, 3 to 5 times more replacing stuff that's junk. So,
well, I can say from personal experience, life cycle cost or total cost of ownership has been, at least in my camp, has been evident since 1972.
Yeah.
So how many years is that?
That's a long time.
See, I'm old.
Yeah.
My first job was working on nuclear submarines. And, we believed in reliability and we believed in making stuff last and not failing. So, yeah, but now when I got over into industry after I left there, not so much. I mean, people would talk about it, but then when push came to shove and you had to put a little money in to do things like your asset registry or buy a higher grade material or buy a longer lasting pump, everybody gets real squeamish.
Yeah.
Oh, I don't know, I can spend money on that. You get the old bull crap. Well, you're polishing uh, what is it? You're over polishing the ball or you're gold plating it. There's all kind of euphemism for it, and it's all crap.
Yeah.
You have to make an engineering decision about using life cycle cost and considering total cost of ownership, and then you have to stick to that policy. And to this guy's question, most people talk about it. Damn few do it.
But do they actually do anything about it? And that gets down to
oh, sorry. They'll say they do. Okay.
Yeah.
They'll say they do, but then they're gone by the time the guys have to live with what they turned over.
Right.
So nobody, holds them to account. Go ahead, Doug. Sorry.
It goes right to component level, by the way, when you're looking at life cycle costs. If you're not paying attention component by component, you can shoot yourself in the foot. Right. Not only with the reliability of them, but having to carry all the different spares. We've talked about that many times. And I can tell you, in all the companies that I've dealt with in my 25 years working in consulting, only two that I'm aware of have actually taken the time to test the components that they plan to be working with, right? And that get motors, pumps, valves, actuators, right? Put them through a series of tests by putting banks of them together and operating them at accelerated rates to see, okay, which ones really last, which ones, right? And then talking to the maintainers to say which ones are easier to work with, right? Because that makes a difference as well. And in doing that, right, and making those decisions, from there on out, these are the brands we use. Here are our select suppliers for valves, pumps, motors, actuators, starters, you name it, right down to component level, to say, if we can keep that down to 2 or 3, and we make sure that one of those 2 or 3 are reliable, we've done ourselves a big favor in the long run.
Yeah. I want to kind of go back to your 5 rights, or what I wasn't in on that because of my faux pas with teams. But in any event, I want to I have a preach about this thing called the reliability process, and it has to do with the way you design, buy, store, install, and start up, operate, and maintain a given plant. And reliability begins in the design. If you don't build it in and from the get-go and use the shop floor guys to help you identify where the defects and the problems are that are causing you extra costs and causing you to lose production and quality and so on, then you're really missing a huge opportunity, as Doug and I have just articulated with those case studies. But I want to talk about each one of those and maybe hit some key questions to ask, I suppose, or some key principles to address. And Doug, you can jump in there on each one with your 5 rights. And anyways, if you're going to design for reliability, I think you need some targets. So for example, do you have a targeted OEE? And let's say you do. Let's say it's world class, 85%. Well, okay, what's your current OEE for a similar process in existing plants? And if it's 65, you better not replicate what you've already done. You better make reliable equipment. You better make changeovers in the process of the product easy. You better have adequate instrumentation. you better use high grade materials and so on. Because if you can't make up that 20% by learning from the process you've already got, then you're not really into it. Or if you expect, in that scenario, if you expect 98% availability of equipment, well, what are you getting on similar equipment? Well, if it's 92%, you better figure out how to get it to 98 based on what's causing you to lose the 8% and so on. So, and you better be, have adequate training built into the process. You better apply, Doug would know this, you better apply RCM principles in the design. And that doesn't mean you have to do a complex analysis. It just means you think failure modes and consequences, and then you take appropriate action in the design. Just think that way, and you'll be better off. And of course, we've said this several times, you got to involve shop floor guys that have been associated with similar plants, similar operations, similar maintenance requirements. So that's that bit. Doug, you comment?
Adding to that, you talked about OEE. If you got a process that's running at 60 and you're looking to put another one and you're expecting 85 out of it, I'm a person that would be saying, you might want to work on that first one a bit, because you may not need the second. Right? You may find you may not need that. But that set aside, some folks struggle with, okay, how are we going to do that? Because we haven't been able to get our 60 up to 85. And that's where you go to folks that are in non-competing businesses, and you start talking to them, right? Yeah. If you're running a web of some sort, like I was in the coating business of film, right? Geez, there's all kinds of companies that coat paper, that coat saran wrap, that coat all different things, right? Go start talking with them and find out who's doing things right, and learn from them. See if you can't get them involved. And I'm one of those that says, see if you can't get a couple of their good people to come help you. Right. Because you don't want to make the same mistakes again. You don't want two things running at 60. Right.
Yeah. And, on your point there about if you're at 60 or 65, I got a couple of points on that. And one is, if I'm the CEO or VP of manufacturing or whatever, and you come to me and you said, well, we need to increase capacity. And I said, well, what's your OEE? And you say 65. And I said, well, what's really good? And you said 85. Well, in my mind, that's a career limiting moment for you.
Yeah.
Now, if you need $1 million to get it from 65 to 85, okay, let's put a plan together and make that happen. But let's not spend money we don't have to until we've used what we have effectively. So, that's kind of an important point, So,
and I know that you have read Bob Hansen's book. That was one of the things that he helped change at Kodak, was he put TEEP into there and said, all right, so you got OEE and TEEP is really utilization. Put the two of those together, and that tells us where we really need to spend our capital.
Yeah.
Right.
Yeah.
If your OEE is struggling, then as you said, let's do an RCM or do something we can use to get that 60 up to 85 or even into the 90s. And if that's not possible, if we're struggling with that process still, and we're actually utilizing it, now we've got a good opportunity to say we probably should spend some capital there. Right.
Yeah. Now, there's lots of other comments we could make, but I'm just trying to hit the high spots here. On the buy part, again, it's total cost of ownership is the, kind of the catchphrase that a lot of people use. And it's very similar to life cycle cost. It's just, more of a purchasing phrase in a lot of companies. And it's looking at not just the price, it's looking at the performance downstream. And what you typically find on average, and it varies pretty substantially from, one equipment to another, but about 25% of your total cost of ownership is in the price. And the other 75 is downstream. It's in the the power costs of, say, running, driving, motors. It's in, the consequential cost of lost production and extraordinary maintenance costs. It's all those other things downstream. So you really have to be, attuned to those two principles. Now, stores is a big issue. And so how does a project guy know what spare parts to keep in the storeroom? Well, you go talk to the maintenance guys and the operating guys, and you ask them about certain equipment, and you say, well, what of this equipment have we had the most negative experience? And the first question might be, how do I make sure the design accommodates that and doesn't incur that? But the second question might be, well, if that's the most common failure, I better have the parts to address that. And as far as the vendor recommendations, you have to be kind of careful. They're going to tend to over recommend because it's in their financial interest. And they also want to ensure you have extra parts when you need them. But the other thing is they may not understand how you operate the equipment. So in the design, you have to make sure you accommodate those issues as a part of your analysis. So let's see, we got a couple of comments here. Yeah, why don't we pause right there? So the storeroom, what fails most often? Talk to your folks, either design those failure modes out or accommodate them in the spare parts that you get. And let's pause there.
Where-based, right? Those are the two things I look at. Are they where-based or are they random-based?
Yep.
Right? If they're where-based, you should be able to plan on when that item is about to fail and order it and get it in, provided you've got the correct amount of lead time estimated. If they're random, then you have no idea when it's about to fail. That's something you probably are going to want to have. It's really, it comes down to, it's almost that simple. One of the things that I've seen companies struggle with, and one that I've been working with recently, is the footprint of their design, right? And that gets into the maintainability. We talk about the 5 rights, right? How maintainable is the asset? And one company in particular that I worked with just found out that something that they installed, and because they got a new contract with somebody, and it boosted, was one of those things that would help boost their sales and keep their people rolling all the time. They did some installation and got things up and running, and they're struggling to stay running. And then all of a sudden they had a really, what I'll call a catastrophic failure. Nothing where anybody got hurt or anything, but the machine basically just crapped out, right? And one of the things they found out about the design when they didn't consider maintainability in that footprint was, gee, we got to shut 2 other lines down to get that thing out, right?
Yep.
And they're like, yeah, for how long? Yeah, a couple days, right? So if they'd given good thought to their design and the way the footprint should have looked, and talked to their maintainers, because the maintainers brought it up right away, right? As soon as they saw where it was going, what are we going to do if that fails? It should have been over here. Well, we can't change that now because then we'd have to change this, and this. So they install it that way. Well, guess what? Murphy's Law says that's what's going to happen, right? And sure enough, it did. About 8 months later, and they're found out that wow, that was a heck of a hit to take. And now they're re-looking and saying, okay, so how should we have done it, right? And now let's talk with those maintainers and where should we put this stuff now, and do we have room for it? Right.
Yep. Let's see. Let me. There were not really questions; they're more like comments. Boeing has paid the price for poor reliability and safety considerations. Yeah, that's that to me, that's kind of incredible. And there may be others out there who, who can correct me if my impression is wrong. But my impression is that that particular design on the 737 MAX had a single point of failure, and it didn't have redundancy, which is, to me, kind of remarkable that you wouldn't design that in, given, the safety and the risk considerations associated with that. So yeah, I'm just amazed they didn't have redundancy for that pitot tube that that apparently failed, and then they wound up having difficulty controlling the aircraft.
Yeah,
So,
and as I recall, it was on top of that, then after they recognized that there was a training issue that,
yeah,
gee, if some folks got the proper training, they recognized it and they had a way to work around it,
yeah,
right? Folks that didn't have it panicked, and
yeah. But
it's
you don't
a
want an
bad thing.
aircraft. You don't want to be in an aircraft at 30,000 feet and have somebody, improperly trained to handle a single point of failure, event. I
Yeah.
mean, to me, that reflects another gross, you know, uh, problem. But I
And
won't.
by the way, that's our point of view based on what's been out in the media,
Yeah,
right? It may be totally different from that, but that's basically what's been printed and what's been said, in terms of what went on.
yeah, and Boeing's a really good company. I don't want to be overly critical of them, but somebody made some decisions in there, probably based on delivery delays and price and so on, and probably wasn't the best decision. Okay, next one says typically 75% of the cost is not included in budget analysis. Now, I think you're right. It goes back to the total cost of ownership. They don't consider, for the most part, that 25%. And few non-reliability folk understand MTBF and so on. Yep, that's true. So you have to explain it to them. so, uh, you know, it's just kind of frustrating sometimes. Folks that make these decisions need to be educated on the implications of their decisions. I've been around companies where the purchasing manager will get up and say, "Yeah, we saved the company, $300 million." This is literally a true statement I've heard. And you go back and you look at their data, and their income and their profit has been fairly flat. Well, that's because they saved 300 million in one hand and they spent it in the other downstream because of poor quality, higher maintenance costs, less production, and so on. So it certainly does need to be accommodated. Had a couple of more quick comments, Doug, and I'll turn it back to you. Installation startup. According to several studies I've got, you're 5 to 10 times more likely to induce defects and failures during startup than you are during normal operation. Well, what does that mean to a project guy? Well, buddy, you better have the right equipment installed with the right standards, with precision effort, precision training and startup, all that sort of thing, or you're going to suffer for it. So, and then the last two, operations and maintenance, design it for ease of operation, for ease of maintenance. And where do you get that information? You talk to the operators of similar equipment. You talk to the maintainers of similar equipment, and you build in budget to accommodate that. And if you don't, you will pay for it later in spades. Okay, I'll stop right there or halt. Doug, comment?
Yeah, both those things are important. As I told you when I came on today, my dad gave me a call yesterday and says, "Hey, I got to replace a water heater, right? Mine's starting to leak out the bottom, and I don't want to wait until I got a flood in the basement to do something about it." So, can you look up where I get the best price on one, and then we'll do it, right? So we get talking about that, and his is an electric one because we have good electric prices in the village that we live in. And I said to him, I had a buddy that used to do this, was his job was doing water heaters, and he said the job that he did most was replacing heating elements for people that don't know how to install water heaters.
Yep.
And they make the mistake of turning the electric on before they've got the tank filled with water, right? And of course, it just burns the heater right out, right? And
Yep.
then they'll call and say, "Well, the heater that I got from Lowe's or Home Depot don't work," right? And well, you blew the element. And by the way, you don't know you have it filled until you turn the water on, you go up to the kitchen sink or they go to the highest level in the house and turn the hot water on in that area until you got water flowing there. That's when you realize that you've actually filled the thing, right? You can get air trapped in there and not have enough to cover the element, believe it or not. So startup is one of those things. And when you're talking about a far more complex process in a chemical plant or a manufacturing plant, having that startup procedure in place and how it's going to be done and who's going to do it and step by step go through it and train your people. Lots of mistakes can be made and they can be extremely costly.
Yeah.
So
I personal story. We're off plant stories now, so I'll share mine. Had to replace my HVAC system, and those things are really expensive these days. And I have a handicapped daughter, and I had to replace hers recently. Now, before I did that, I didn't go out and try to find the cheapest one. I called my nephew, who's in that business, and I say, I want to know the best HVAC system out there. And he said, it's expensive. And I said, I don't care. If it lasts twice as long, it's cheap. So that was my modus operandi. I really try to practice what I preach in doing these things. So anyways, that's my HVAC story. And that happened for both my home and my daughter's home. So you might want to spend a little extra because you get, and then after that, you got to, I do the, spring and fall checks, change the filters, all that sort of thing to assure that the reliable equipment is maintained in a reliable mode. So, all right. See, I reckon we're just about done, aren't we, Doug? Yeah.
We are pretty close on that window.
Okay. All right. Well, I'm done talking. So,
yeah.
Any other questions or comments from folks out there? If not, we'll let you go a minute or two early. I'm going to go kayaking with my daughter and grandson. So,
yeah. Again, the maintainability piece, I am big on that. I've also seen places where they installed some stuff that all of a sudden, gee, if you'd installed it 90 degrees different than what you did, mechanic could have come in there and pulled that pump out and slid it off to a cart, no problem. The way you installed it 90 degrees off, now you got to go install a monorail above it and get a chain faller come along to lift the pump or motor out and then have that on a trolley so you can get it out to an aisle and move the doggone thing. So How much expense did you just add to your project by not thinking things through? Right. So you got to have that now rated for how much can it lift, right, and installed properly. And lots of times they don't even see that until a couple of years down the road when they have to replace the first item and they go, oh, holy smokes. Now, where's the money to do it?
Yeah. The
project's closed.
In the for what it's worth category on submarines, we had drawings for that when we designed the submarine. How you going to get it in? How you going to get it out?
There you go.
And procedures and standards and so on. So it's what you do. Of course, the government's got a lot of money, I suppose. but anyways, enough said, guys. Let's go kayaking or whatever you've got planned for the afternoon, Doug. Okay.
Just a walk. That's it.
All right.
Have a great day.
Yes, thank you both for a great conversation. And as we wrap things up today, On behalf of the entire team here at Mobius Connect, we thank our wonderful audience for joining us here today. Just as a quick reminder, you can see past episodes of Connect Conversations on YouTube and Reliability Connect. Be on the lookout as new episodes usually air every other Tuesday at 2 p.m. Our next one coming up is Case Studies Root Cause Analysis, RCA, with special guest Bob Latino. So we hope you will all join us for that one. You can view Reliability Connect as you did for this one and sign up to get notifications of that. If you are interested in engaging with other industry professionals or would like to participate on the industry's live feed and forums on Mobius Connect, you can visit mobiusconnect.com to create your free profile, and be sure to follow us on our social media at Mobius Connect to stay up to date with the latest community happenings. If you do have any questions at all or would like to get in contact with Doug or Ron, you can email our team at info@mobiusconnect.com. Thanks again for joining us. Have a great day, and we hope to see you on the next episode.